Okay, let's say I have an aluminum. I buy, I don't know, 500 rods of aluminum that have a reported strength of 350 megapascals plus or minus 25. And this is given as my average plus or minus the standard deviation. Okay, so I know that my average is 350, but the standard deviation is 25 megapascals. And I want to know how many of them, of the 500, will have what's the probability of how many will be between 380 and 305 megapascals. Okay, so assuming a normal distribution. So I have my non-dimensional variable z, which is x minus mu over the standard deviation. So I'm going to do it for both limits. 305 minus the average over the standard deviation will give me a minus 45 over 25, which is minus 9 over 5, or minus 1.8. And the probability, that's z1. The probability for z1 would be going to the table for my normal distribution and looking for 1.8. So here, 1.8, I have 0.0359. 0.0359. Okay, and then for the other z2, the other limit, it would be 380 minus 350 over 25. This would be 30 over 25, or 1.2. So the probability for that z2 would be finding that 1.2 in this table. So go to 1.2, and its probability is 1151. 1151. Okay, so what is the probability? This is the probability for them, for the strength to be lower than 305, and this is the probability for the strength to be over 380. So if I do 1 minus these two probabilities, 1 minus 0.0359 minus 0.1151, which is 0.849, and I multiply that probability. I'm going to write this as the total probability, and I multiply that by the number of samples that I have, which is 500. 849 times 500, I would get 424.5 rods. So just to be safe, I would say that 424 rods will have an S, a strength that is between 380 and 305. Okay. Now let's do another one. Let's assume same material, but let's assume that I don't have the standard deviation. I bought the material, and they say, well, it's 350 megapascals, but of course there's going to be some uncertainty there, and I want to know what the standard deviation for that is. If I know that out of the 500, let's assume the same numbers, 500 rods, I already know that 45 of them failed. And I know that they would only fail if my strength is lower than 310 megapascals. Okay, so I know that they failed, it was because the strength was lower than 310 megapascals. Let's say that for some reason I know that the maximum stress is this. So if they failed, it was because the strength was below 310 megapascals, right? And I want to know what the standard deviation is, so that when I buy from that vendor, once again, I kind of know, oh, obviously the batches are going to change, but at least I have an idea of what the standard deviation that they didn't report is, okay? So this one's easy. If I have 45 out of 500, this is a 0.09 probability of failure. That means that the probability of Z1 was 0.09. So what would my Z1 be? I go to the table and I look for the probability anywhere over here for something that is close to 0.09. So I see here 0.0951. If I keep going down, I find 901. So that's pretty close to 0.09. If I go one more, I'm way below. If I want to be precise, I would just interpolate between these two, but this one's close enough. So I'm going to go to 1.3, 1.304. 1.34, sorry, this is the second decimal. So 1.3, 30, 31, 32, 33, 34. 1.34, a Z of 1.34 gives me a probability of 0.09. So 1.34, right? And I know that Z1 is my non-dimensional variable, which is x minus mu over the standard deviation. So from this, I know that the standard deviation is going to be x minus mu over Z1. X is the property that I'm looking for the probability of, 310. The mean was reported to be 350, and the Z that I found is 134. So this would be minus 40 over 1.34, which is 29.85, 29.9 megapascals. So there it goes. My answer is that the standard deviation for that batch that I bought is 29.9 megapascals. Okay, so I got something that was reported to be 350 megapascals. I got 500 of them, but 45 failed, and I know that they would only fail if the strength was lower than 310 megapascals. With that information, I know that the standard deviation that should have been reported was close to 29.9 megapascals.